Hello, in this video we're going to be talking about inverse functions and their derivatives. So they follow this weird sort of thing. What we're saying is that if you've got an inverse function's derivative, it is 1 over a composition of the original's derivative evaluated at the inverse, given that this is not equal to 0, which is a big mouthful, but it makes a little more sense once we can do one. So we want to figure out what the slope of the tangent line to this inverse is at x equals 1. So we need to figure out what g negative 1 derivative is at negative 1. So that is asking us to figure out what is 1 over, we need to figure out what g prime is at g inverse of negative 1. So bit by bit, what we're going to start with is this value of the inverse at negative 1. Now, you can see we've got a negative 1 right here, but that would only put it into the original function. We want to know what we put into the original function to get out negative 1 right here. So if we put 2 into g of x, we get out negative 1. So if we put that into the inverse, we'll get back out the 2, because that's what inverses do. If you put something into it and then you put that into the inverse, you get the same thing back. So this value of the inverse at negative 1 is 2. So now we're looking at 1 over the value of the derivative at 2. So the value of the derivative at 2 is negative 3. So this is going to be 1 over negative 3. That is the value of the derivative. That is the value of the inverse's derivative at negative 1. To make this a little bit more clear, now we're calling the inverse and the original function different letters, just to make it a little bit more clear for us. So g of x is the inverse function, and f of x is the original function. So again, what we're looking for is what g prime of 3 is. So that's going to be 1 over the original's derivative evaluated at the inverse value of 3. Now this one was really nice. We didn't have to use a table to translate it. It was just right there at 1. So we want to do 1 over the value of the derivative at 1. So I'm going to figure that out over to the side here. So f prime of 1 equals, let's see, so power rule, 1 squared plus another power rule, just a regular 1, and then the derivative of x is going to be just a 1. So that is 3 plus 2 plus 1, that is 6. So the value of f prime of 1 is going to be 6. So that is 1/6. G prime of 3 is 1/6. Ah! What is this? These are gross. Sorry. So trig functions inverses, their derivatives are these big nasty things. I will tell you right now that these two will occasionally show up. Not a lot, but they will occasionally show up. These are very rare, the derivative of inverse tangent and inverse cotangent. These two, never seen them. Haven't shown up. I don't know. They're only legend. So mainly make sure that you're familiar with inverse sine and inverse cosine. But you can notice that there is some similarities, that these ones just have a negative that these ones didn't. Is the only difference. Let's try using this thing out. So the derivative of inverse cosine of x squared is going to, so y prime is just going to be the derivative of our inside, which is 2x, slap a negative on that, over the square root of 1 minus our inside just squared. So we have to square that x squared, and we get an x to the 4th. And that's it. That's all you have to do. If you've got that memorized, it's really easy, but it's just a matter of memorization. Let's do another example. This is the derivative of inverse sine. So y prime is going to be the derivative of that inside. So the derivative of this is just going to be a square root of 2 over the square root of 1 minus our inside squared. So that square root gets squared and becomes a 2. The t becomes squared and becomes a t squared. So we get 2t squared. 2t. And that's it. We're not in the simplification game. I don't want to do anything else beyond that. In this example, we want to deal with the derivative of inverse cotangent. So I've got my formula up there. To do this derivative, all we got to do to find y prime is do the derivative of our inside, which is 1/2 t to the negative 1/2. There's a negative in front of it from our little formula there, over 1 plus our inside being squared. So that is just a t. Let's see, is there anything that we want to do to simplify that? Well, I mean, we could bring that t to the denominator, and that 2 would also go to that denominator. So it would be negative 1 over 2 square roots of t times a 1 plus t. Yeah. So that might be another way to write it. I don't think there's anything wrong with writing it the first way around, but multiple choice simplification, it's kind of nice to see that. That is it for our inverse trig functions, these reverse cards. So make sure that you know this formula for finding the derivative of an inverse. It is just a composition of the derivative of the original at the inverse. In terms of these, you want to make sure you know these first two. These two are very, very rare, if at all, and these last ones are only legend. So if you want to learn them, I think it is good to know them. But if you're just referencing them off of your cool calculus card, that's okay. Um, and that's it. Uno reverse. Hooray! Inverse trig functions and inverses. And I'm rambling now. Goodbye. Goodbye.